ourselves a little test. My buddy Richard sent me up this brand new Xforce. It's got the PP100s in it, and it was all burnt up. So instead of putting PP100s back in it, we went back and put a match set of Toshiba 2879s in it. Now, if you guys can remember from yesterday, I had an Xforce 4-pill base station that had Toshibas in it that I redid, and we were getting just like 1400 out of it, and we were hitting it with the Connex 4400 Turbo. And I wanted to show you a before and an after. Okay. Now that had an iron core transformer in it. This has got 330 amp LED switch mode, not made by Meanwell, but their copy power supplies in it, which should be enough to carry this. But this is completely stock the way Xforce would send it to you. Haven't modified this at all, other than I changed out the transistors. I wanted to do a before and an after to show you the difference between what I do with the inside by changing the power wires, the output performance difference in the box. Every watt that we gain from this point forward demonstrates that we've increased either the efficiency of the circuit, the efficiency of the electrical delivery system, or its input or output tune. Okay? So now we haven't changed the voltages on these. All I did was change the transistors. So what we're going to use is a 1000 watt slug in average, 1000 watt slug in PEP in 2x position, a 5 watt slug, the Connex 4400, okay, and a 5 watt slug in reverse between the Connex and the radio. And we're going to show you a before and an after. So I'm going to do this, set up the stock Xforce way, and then I'm going to shoot another video here after I modify the power positive leads, and we're going to change the resistors on the output circuit, and then we're going to do the input tune a little bit differently, and we're going to adjust the output tune a little bit differently. And I bet you that we see a little bit more performance. The reason I brought up the amplifier from last night is because this has got 2 more transistors than that. And I'm telling you right now, the way this thing sits stock, so I'm skipping over a step. Let me go back down to 1x. Audio. So we're going to put about 45 or 35 bird and about 100 watts peak into this amp. Audio. We are in 2x. So we're going to do 100 watts worth of drive. Audio. So we're seeing what, 12, 1350? Because this would be 1000, that would be 12. And we're falling between the 12 hash mark, which is the 15, and this next big mark, which would be 14, 16, 18, 2000. So we're seeing about 1300 peak and about 400 bird. Okay. Stock from Xforce. And let's see if we can scooch a couple more watts out of this. I'll be back. We did the before. Well, let's do the after. So, anyhow, Mr. R, this is the after shot. Now, I changed out the 100 ohm. Those are 2 watt flame retardant resistors. It was really encouraging to see flame retardant resistors inside of these boxes. You know, there's this big running debate, and it's been going on for years in the little chat groups. Is 2 watt significant, or is 5 watt? Is he trying to cover up and balance? What's the deal? This is the first Xforce I ever opened where I used flame resistant resistors. Okay. These buffer resistors, flyover shock resistors, flyback resistors, however you want to refer to them, they don't do anything until you try to overdrive them. They cause a balance between the input and the output transformer. They allow a pathway for the RF to go after you oversaturate the component, and they act as a shock absorber in the electrical system for the RF. They really don't do anything unless you're over deviating the circuit. So that's why they can be 2 watts. I just buy 5 watt resistors. I use them on everything. Now, you can use a 2 watt on your output combiner. Why? Because they don't do anything until you have a problem. Until you have one of these 3 amplifiers, that's an amplifier. One of these 3 amplifiers go bad. Something falls out of whack. Either the tuner cap goes out of balance, or the drive wire pops off, or one of the transistors go bad. They sit there and they're idle and they don't do a whole lot. There's a little bit of initial imbalance when the circuit starts to energize, and the RF coming from each one of the outputs to be combined together. And they suck up that little tiny bit of initial imbalance. Otherwise, they don't do anything unless it's in a high RF environment. If it's in a high RF SWR environment, like high standing wave, is what I mean by high RF environment, high standing wave. That's the only thing that sits between you and your transistors and it coming back to your components. That, and when something goes bad, it gives the operator 1 or 2 more keys to realize there's something wrong with the box. That's it. You can put 10 watt resistors there. It doesn't matter. Something's going to fall into imbalance. The circuit's going to go into imbalance. Those resistors are going to get hot. They're going to start to produce smoke. The operator's going to smell the smoke. Because some of these guys, they don't even run meters, and they realize, oh, there's a problem, better shut the box off. I like the 5 watters. It buys the guy a little bit more time. And time from what? When something falls out of imbalance, you're going to go key, component fails, a third of the box shuts off, RF starts to back up, fly back at that circuit, and the only thing that's standing there in between it is this little resistor. Resistor gets hot, starts to smoke. Phone's ringing right in the middle of the video. Starts to smoke, operator shuts it down. If he doesn't smell the smoke, he sees the watts drop off, key it, imbalance, key it, imbalance, key it, imbalance. This sucker's gone. It's not protecting the other circuits anymore. This gives you a couple more keys. And you know what? There's about 3 cents difference between the 2 resistors. I'll use 5 watts throughout. Is it really necessary? Absolutely not. Is it better? Sure, absolutely is. So anyhow, the before video was a completely blown stock. Now we've been in here and we BBI'd it. We did our BBI thing to it. And what do I mean by my BBI thing is I go and I look at the input tune. I see how much reflect is coming from the input portion of the box back to the radio. Okay. If the RF can't go in, it can't get rectified, i.e., it's not going to come out. Showed all this in the intro video. Well, we got the input tune laid down. I took out the output tuning cap and replaced it with a variable capacitor, brass tube basically. Had to take 20 puffs out of the input tune. Had to take 12 puffs out of the output portion. Didn't change the inductance tuning whatsoever. And the box stood right up. Now remember, if we can think back to the beginning of the video, we were seeing just roughly about 400 bird. And we were seeing about, 1350 in peak power? Hitting it with the Connex, right? So let's go back through our same processes again. Barefoot Connex at audio. Same amount of drive. Haven't changed this at all. About 100, 110 watts worth of drive coming out of the Connex. This is what that thing's supposed to do. Going into the 4-pill. Check this out. Hello. We just laid it in a corner, right? At a 2x position. Turn this off. Remember, in 2x, right there at that 50, right there, it's 1,000, 12, 14, 16, okay, 18, 2,000. So before we were just tickling, right at about there. It's about 1380, and we're seeing about 400 bird, right? Hello, audio, audio. Hello, audio. BBI. Here's our input tune now on the Connex, or on the hello, audio. Hello, audio. I found 220 peak watts in this box and about another 115 to 120 bird watts. The same amount of drive, just by upgrading the electrical system and polishing the tune. I'm not saying this box didn't work when it came in here. Well, it didn't work when it came in here because it was broken. I'm not saying that these don't work. I'm just saying if you spend more time with it and add a little bit bigger parts to it, it works better. For every watt more that we can get out of the box, it means the circuit's a little bit more efficient. The parts are going to run cooler because they're not having to work as hard, either to overcome output inefficiencies or pull more current because they're not getting enough amperage. Just saying. I'm not here to bag on this name, and I'm not here to bag on anybody else. I'm just pointing out that this is what I do, before and after. I take a pre-existing amp, polish it, go through it, do my thing, and I get a little bit more out of it. Is that the max this box can do? Oh, hell no. No. But this box is screaming. It is running pretty good for 120 watts worth of drive. You can hit this a little bit harder, Mr. R. You definitely can. You get about another 100 watts out of it, and that's all you're going to see is returns. But I know the way that you're going to run this thing is pretty straightforward. Now, the other thing I want to point out is that there's this very misleading thing going on right now. Another phone call. Everybody's putting sideband delays on their stuff, but this thing isn't biased for sideband. It's Class C. Okay? If you want to run sideband, all this is doing is allowing you to run with a 1 watt dead key or lower. If you want to run sideband, make sure your box is biased for sideband on the inside. You cannot run Class C. I mean, I guess you could. Your audio is going to be all chopped up. The parts are going to be friggin' having a hard time turning on and off, and you're going to end up buying new transistors real quick. You can't run Class C unless you put a little bit of bias on the input transformers. Oh, here comes another phone call. Completely different number. Gentlemen, I got to go. As you can tell, the phone's ringing. I appreciate y'all. Mr. R, I'm going to put the tin on it and send it back to you. Appreciate you sending this up, giving me the opportunity. We'll get on to the other Xforce you got here for repair. We'll get that out the door next. My name is BBI, without a shadow of a doubt. Come check us out. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out. www.bbiamps.com. I appreciate your all support. I'll see you.